Hi, I am Richie and welcome to my channel. Today our discussion will be on circuit theories again. We started a series on circuit theory and we said that before you can solve circuit theory very well, you need to understand some basic properties of a circle. Last we looked at about 4 of those properties and how to apply those properties in solving questions. Today we'll look at the other properties and how to apply them with the other ones we learned earlier in solving problems. Please, if you have not watched my videos on the first one, check it out on YouTube, Circuit Theory Part 1. So this will be our Circuit Theory Part 2. This will be a very interesting engagement, so please come along with me. So we look at 4 of the property. Let's talk about the 5th one here. The 5th one is saying when we have 2 equal chords, okay, this is the center of a circle. And we have a chord sustain and angle at the center of the circle. Another chord again, sustain and angle at the center of the circle. And the chords are equal. As far as the chords are equal, then the angles they sustain at the center of the circle will be equal. So we say A is equal to B. So for instance, if we have a circle like this, and this is the center, and we have a chord sustain an angle at the center of the circle, let's say O. Another chord sustain an angle at the center of the circle, O. And let's say this angle is 20 degrees, and this is X. And the chords are said to be equal. Then the value of X is also 20 degrees. As far as the chords are equal, and they sustain an angle at the center of the circle, then those angles are also equal. I hope you get this property. The next one is this sieve property. So the sieve property to say that when 2 equal chords, okay, sustain an angle at the circumference of the circle, those angles are also equal. Thus, we have a circle and a chord. This chord sustain an angle at the circumference of the circle like this. Another chord like this, sustain an angle at the circumference of the circle. As far as those chords are equal, then the angles they sustain at the circumference of the circle will also be equal. So we say S is equal to Y. So for instance, if we have a circle and maybe we have a chord, this, and that chord sustain an angle, let's say the angle is 30 degrees, okay? Then another chord sustain an angle at the circumference, and that angle is X, and the chords are said to be equal, then the value of S is 30 degrees. I hope you get that. The next property is the 7th one. So the next property, the 7th property says that when we have a cyclic quadrilateral, a cyclic quadrilateral means it's a quadrilateral in a circle. And quadrilaterals are plane shaped with 4 sizes. So you have a cyclic quadrilateral and it touches the 4 sides of the circumference of a circle. The sum of the opposite angle of those quadrilaterals add up to is equal to 180 degrees. For instance, so if we have a circle like this, okay, and we have a quadrilateral touches the circle in this way, okay, then we say this quadrilateral is a cyclic quadrilateral as far as it's in the circle. Then we say the angles they make, they are opposite angles add up to 180 degrees. So let's say this is A, B, C, D. Then we say A plus C equal to 180 degrees. And B plus D also equal to 180 degrees. B plus D also equal to 180 degrees. I hope you get that. So the opposite angles of a cyclic quadrilateral sum up to 180 degrees. Very, very necessary. Let's look at the 8th property. So any line drawn to touch the circumference of a circle but does not cut the circle, we call that line a tangent. So this line here, look at this line, it's called a tangent. So the 8th property is saying that the angle that the tangent makes with a chord, okay, so this chord the angles that the tangent and the cos make is equal to the alternative angle at the other segment of the circle, not the segment at which the tangent, that very tangent and the chord meet, and that very tangent and the chord meet. So you see, this is a segment. This is another segment, if you remember very well. So he said that the angle that the tangent makes with the chord is equal to the angle at the alternative segment. So let's say this is the angle at an alternative segment. So you see that this chord makes an angle with this tangent. However, this chord did not make the angle with the tangent, no. So this angle here is equal to the angle, the alternative segment. So we say x is equal to y. Another way is that, look at this. The chord, you see that the angles that the chord and the tangent make with the circumference of the circle is equal to the angle that the chord makes with the circumference of the circle. So to get it, the angle that the tangent makes with the chord at the circumference of the circle is equal to the angle that the chord makes at the circumference of the circle. So we say S is equal to y. Please keep this thing very well. We'll be applying them. Now, if you look at other books, they have 8 properties. I'll add one to it so that you get a concept very well. So we say any line drawn from the center of the circle to the circumference of the circle, that line is called radius. And we said 2 radius are called radii. So this line is, let's say O is the center of the circle. This line is drawn from the center of the circle to the circumference of the circle. This is another line also drawn from the center of the circle to the circumference of the circle. Then we say these lines are radius. Then if they are radius, then this line is equal to this line. As far as this line is equal to this line, then the angle here must be equal to the angle there. So please get it right. As far as the line is drawn from the center of the circle to the circumference of the circle, the angles that they make with the chord as the base, those angles are equal. Please get that concept very well. You may not find it in other books, but we are going to use it in solving questions. Now that we know all the properties, the ones we learned previously and this one, please check out my videos on property 1 to 4. So today we look at the property 5 to 8, and I've added one to it. We are going to apply all these properties to solve some problems. So come along. So let's look at our first question in applying our property we have learned to solve. They say, in the diagram below, O is the center of the circle, and line QR is equal to line RS. So line QR is equal to line RS. You should find the value of the angle marked X, this angle. So remember, we say when two equal chords, so you see these chords are equal. 2 equal chords sustain an angle at the center of the circle. Those angles are equal. So we can say the angle here is equal to the angle there. So angle ROQ, that's ROQ, this angle is equal to angle ROS, all equal to 50 degrees. So since we know our angle ROQ, so we know angle ROQ to be 50 degrees and angle ROS to also be 50 degrees. They are the same. Please, as far as the chords are equal, they sustain an angle at the center of the circle. Those angles are equal. Then we know the angle here now. The angle here, that's angle SOQ, is equal to this angle plus this angle. So what do we say? We say angle SOQ is equal to angle ROQ plus angle ROS. So angle SOQ will be equal to, what's ROS? ROS is 50 degrees plus ROQ is 50 degrees and ROS is also 50 degrees. Then you can say angle SOQ is equal to 100 degrees. So the angle here is 100 degrees. Remember, we have a chord here. Look at it. There is a chord. And the chord sustains an angle at the center of the circle. the same chord sustain an angle at the circumference of the circle. Remember that property. We said twice of the angle at the circumference of the circle will be equal to the angle at the center. Remember that. So we can say that twice of angle SPQ is equal to angle SOQ. And we know angle SOQ to be 100 degrees. So twice of angle SPQ is equal to angle SOQ. So twice of angle SPQ is equal to angle SOQ. So what's our angle SPQ? Angle SPQ is x. So say 2 of x will be equal to angle SOQ. Angle SOQ. And angle SOQ, remember, is 100 degrees. So say 2s is equal to 100. When divide both sides by 2, our s is 50 degrees. I hope you get that. So we apply the property we have learned today as well as the one we learned previously to find the value of x. Now let's look at our next question. So let's look at our second question. They say in the diagram, this diagram, line DE is a tangent. Angle CBD, this angle is 54 degrees. And angle ACB, this angle is 76 degrees. They say find the value of x and y. That's x and y. So what do? We use the property of a tangent. Remember, we said that the angle that the tangent makes with a chord is equal to the angle at the alternating segment. Then we can say the angle here is equal to the angle here. Simple. So our angle CBD, the angle CBD is equal to angle BAC. So let's get that constant first. So we can say angle CBD is equal to angle BAC. I hope you get that. This angle is equal to the angle. So what's angle CBD? Angle CBD is 54. So you say 54 degrees is equal to angle BAC. That's BAC, this angle here. And that's x. So x is equal to 54 degrees. I hope you get that. So our x, the value of x is 54 degrees. Now we need y. Look at it. You see that this is a straight line. The line BD is a straight line. And angles on a straight line add up to 180 degrees from coordinate geometry, plane geometry 1. So we need this angle here, the angle here. So that when we add this angle to this angle to this angle, we'll add it will be up to 180 degrees. And look at the triangle. Triangle ABC is a triangle. See the shape ABC is a triangle. And the sum of interior angle of a triangle will be equal to 180 degrees. So we said the angle here plus the angle here plus the angle there will add up to 180 degrees. So we say our angle ABC plus angle ACB plus angle BAC will be equal to 180 degrees. That's angles in a triangle. What's angle ABC? We don't know. That's the angle here. We don't know. That's what we are finding. So angle ABC plus angle ACB. ACB is 76. So that's 76 plus angle BAC. BAC is x. So x will be equal to 180 degrees. So angle ABC plus 76 plus x is 54, will be equal to 180 degrees. So angle ABC plus, so 76 plus 54, that will be 130, will be equal to 180 degrees. So angle ABC will be equal to 180 minus 130. So angle ABC is equal to 50 degrees. So now we know that this angle here is 50 degrees. That's what we find here. ABC, angle ABC is 50 degrees. And we said that angles on a straight line add up to 180 degrees. So we can say angle ABE, that's this angle, plus angle ABC, this angle, plus angle CBD, this angle, will add up to 180 degrees. So our angle ABE plus angle ABC plus angle CBD will be equal to 180 degrees. So our angle ABE is y. So we say y plus angle ABC is 50. So plus 50, then plus angle CBD 54. Angles on a straight line will add up to 180 degrees. So y plus 50 plus 54 will be 104, will be equal to 180 degrees. So our y will be equal to 180 degrees minus 104. So y will be equal to 76 degrees. So we know x to be 54 degrees and y to be 76 degrees. I hope you get a concept. I hope you understand that. So let's look at our third question. A very interesting one. I say in a diagram below, C is the center of the circle PQRS. So PQRS. The quadrilateral CPSR is a rhombus. Find Q and X. That's the angle here Q and the angle there X. So before you can solve this question very well, you should know some properties of plane shapes. The opposite angles of a rhombus are equal. You should know that the opposite angles of a rhombus are equal. So we can say that if CPSR is a rhombus, then this angle here is equal to the angle here, and the angle here is also equal to the angle here. It's very, very necessary. So we need the angle here. We need the angle here. When we equate, when we got the angle here and we get the angle here, we can equate. Remember that property. Twice of this, if this is a chord, PR is a chord. Twice of this angle is equal to this angle. So we can say twice of angle PQR, that's the angle here, will be equal to angle PCR. So our angle PQR is Q. So we say Q, twice of Q, we go to angle PCR. So our angle PCR is equal to 2Q. That's when the chord sustains an angle at the center of the circle. That same chord sustains an angle at the circumference of the circle. Twice of the angle at the circumference is equal to the angle at the center. So we know that. Also, when a chord sustains an angle at the two opposite sides of a segment of a circle, if you remember that property, the sum of those angles will be equal to 180 degrees. So we can say that our angle PSR plus angle PQR plus angle PQR will be equal to 180 degrees. So what's angle PSR? So our angle PSR plus PQR is QAD, will be equal to 180 degrees. So angle PCR will be equal to 180 minus Q. And we said that if CPSR is a rhombus, then the opposite angles of a rhombus are equal. So we can say angle PCR, this angle, and is equal to angle PSR. So we can say angle PCR is equal to angle PSR. Very, very necessary. Remember, angle PCR is 2Q, and angle PSR is 180 minus Q. So, if they are equal, then angle PCR, which is 2Q, will be equal to PSR, which is 180 minus Q. How do we do? We can get 2Q plus Q will be equal to 180 degrees. Then 3Q will be equal to 180 degrees. We divide both sides by 3. Our Q is 60 degrees. 180 divided by 3 is 60. Then we have found the value of Q. The value of Q to be 60 degrees. Also remember, just today, I said that when we have a diameter, look at it, a diameter sustain an angle at a diameter, any line draw from the center, it says C is the center. So any line draw from the center to the circumference is a radius. And this is also radius. That means this line is equal to that line. Then the angle here is equal to this angle here. Remember very well. So let's say if the angle here is y, then the angle here will also be y. And we know this angle. The angle, twice of this angle is this. That's angle PCR. Angle PCR is 2Q. So we can say angle PCR is equal to 2 times 60. That will be equal to 120 degrees. So if PCR is a triangle, then the angle here, which is 120 degrees, plus this angle will be equal to 180 degrees. Then we can locate the angles here. So we can say y, that's angle CPR, y, plus angle PRS, this again, plus angle PCR will be equal to 180 degrees. So we say angle PCR plus angle CPR plus angle PRS is equal to 180. That's the angles in a triangle. So what's our angle PCR? PCR is 120. So you can say 120 plus angle CPR. This is PCR. Then CPR. CPR is Y. We can say Y plus angle CPR. CPR. That's CRP rather. So CRP. Sorry for that. So it's also Y will be equal to 180 degrees. And you can say 120 plus 2Y will be equal to 180 degrees. So I have 2Y will be equal to 180 degrees minus 120. 2Y will be equal to 60. On divide both sides by 2, our Y will be 30 degrees. So we have found out that our angle here is 30, and this is also 30. Now we need the x. Remember, PQR is a triangle. Then the sum of interior angle of that triangle will be equal to 180 degrees. That's angle QPR, this angle here, the whole of this angle. Remember, QPR will be x plus 30. Then angle PRQ, another x plus 30. Plus angle PQR, which is the Q. And Q, we find the Q to be 60 degrees. When we add those angles, we can equate it to 180 degrees. So I say our angle PQR plus angle QPR plus angle PRQ will be equal to 180 degrees. So this angle plus this angle plus this angle is equal to 180 degrees. So angle PQR is Q. So we can say that Q plus angle QPR. So QPR is x plus 30, if you remember very well. And our angle PRQ is also x plus 30. So we can say Q plus x plus 30, that's for QPR. Then PRS is also x plus 30 will be equal to 180 degrees. So what's our Q? We find Q, look at it, to be 60. So we can say 60 plus x plus 30 plus x plus 30 will be equal to 180 degrees. So when we group like this, we have x plus our x plus 60 plus 30 plus 30 will be equal to 180 degrees. So 2x plus 60 plus 30, 90, 90 plus 30, 120 will equal to 180 degrees. 2x will equal to 180 minus 120. 2x will equal to 60 degrees. On divide both sides by 2, our s is 30 degrees. Then you can say angle Q, which they ask us to find, is 60. This one is 60. Then x is 30 degrees. I hope you understand this. Please play over the video and you'll get a concept. Okay, we'll solve our next question. Before we do that, please remember to subscribe to my YouTube channel if you are here too, and click on the notification bell. Please keep your comments coming. Your comments keeps me going. So keep your comments coming. So they say in the diagram below, ABCD is a quadrilateral. Find the angle marked X and Y and Y. Find the angle marked X and Y. Okay, so this is a cyclic quadrilateral. Because a quadrilateral in a circle that touches all the four parts of a circle. So it's a cyclic, all the four circumferences. So we said that in a cyclic quadrilateral, the sum of the opposite angles are equal. So we say x plus 80, this angle will equal to 180 degrees. So x will equal to 180 degrees minus 80, s is 100 degrees. Also, y plus 85 will equal to 180 degrees. Y will be equal to 180 degrees minus 85. So y will be equal to 95 degrees. I hope this is very simple. Yeah, I know you can do this. Okay, so I'll leave this question with you. So as an assignment, please drop your answers in my comment box so that I will see if you are correct. They say in the diagram below, O is the center of the circle OQR. The center of is the center of the circle. Angle OQR, that's angle OQR, is 32 degrees. And angle MPQ, angle MPQ is 15 degrees. So calculate the value of angle QPR, that's this angle, and angle MQ, that's this angle. Please solve it and leave your answers in my comment box. Until we meet again, please, my name is Richard.